Hello everyone. So today I'll be discussing question number 37. So in this question, the excitation wavelength of laser in Raman effect experiment is given. If the Stokes line is observed at this frequency, we need to find out the occurrence wave number for anti-Stokes line. So this question is all about Raman effect. In Raman effect, we generally study the material at molecular level. Suppose we have some material and it consists of molecules, and now we are radiating it with some light source. So what will happen? The molecules in it will interact with the radiation. That means matter interact with radiation and it will scatter light. It will scatter photon radiation. If suppose the scattered light is of same frequency as of incident light, then it is called a Rayleigh scattering. But if suppose molecule absorbs some energy, so the scattered radiation will have energy h nu minus delta E, and this is called Stokes line. Since the energy is reduced, so it is of higher wavelength. Now the case where molecule provides some light to the radiation, so the radiation will have more energy than the incident radiations. So it is the occurrence of will get anti-Stokes line for this case. When molecule provides energy, like that means it is coming from excited state to ground state, then only it is radiating some energy, and the photon radiation that we are getting is of high energy than the incident radiation. So in that case, anti-Stokes line will occur. So it is of low wavelength. Then the wavelength of incident radiation. I am saying higher and lower wavelength, and it is in reference with the incident radiation. Okay. Now we'll see. So the Raman shift is equals to for anti-Stokes case. So the frequency of radiation is greater than the incident frequency. And for Raman shift for this is for anti-Stokes case, and this is for Stokes case. So Raman shift for Stokes and will be incident radiation minus this is occurrence of Raman shift. So it will be Stokes, the frequency of Stokes radiation. So the shift, the wave number, it is a reciprocal of wavelength, and this is like wave number. This is not frequency, this is wave number. Okay, so now 1 upon lambda as upon 1 upon lambda n naught, equate both of these for anti-Stokes and Stokes. The Raman shift that we are getting, this is the wave number. The Raman shift that we are getting, equate both of these, so it will be 2 upon lambda naught is equals to 1 upon lambda for anti-Stokes, and this is for Stokes. 1 upon lambda as is equals to 2 upon lambda naught plus 1 upon lambda s. No, I think it is okay, minus 1 upon lambda s. So it will be 1 upon lambda for anti-Stokes line is just put the value. Now we know this is 546. nanometer, and this is 552. So it is Stokes line. So we know Stokes line occurs at a wavelength higher than the wavelength of incident light. This is 552 into 10 raised to the power minus 9 minus 546 into 10 raised to the power minus 9. It is 546, 552 into 10 raised to the power minus 18. This is 1104 minus 546. So it is 546, 552 divided by 558 into 10 raised to the power minus 9. So after solving this, you will get lambda as is equals to 540,129 minus 10 meter. Lambda as is equals to 540.129 nanometers. See, this is lower than the incident wavelength, 546. So we know our answer is correct. If suppose while solving this question, if you are getting anti-Stokes line higher than the wavelength for the anti-Stokes line higher than the incident wavelength, that means there is some calculation problem. So again, go back and see what we have done wrong. Now to find out the wave number, it is just reciprocal of wavelength. So it is 1 upon 50, 1 divided by 540, 129 nanometer. So it will be, if you solve this, so it will become 1, I'm directly writing the answer, 18514 centimeter inverse. 18514 will be the answer. Thank you.